In this video, I'm going to do a video review, or I should say Jack and I are going to do a video review of the practice final test for grade 6 period 2. Okay, the first part of the practice test has to do with vocabulary. We went over this in class, so I'm going to be relatively quick here. The first one, which of the following is an expression as opposed to an equation? There's that word equation. Remember, equal is the word equal is the prefix of the word equation. Therefore, that's an equation, but this isn't. If it's not an equation, we call it an expression. So the answer to this one would be the one without the equal sign, namely 6x. Okay. This equation represents which property of addition? Excuse me. You see these parentheses? We consider x and y associates. If they're sitting together in the same room, they're associating with one another. That's how I think of it. So you're allowed with addition to put parentheses here and then switch them. I see that. I think about associates. That's the associative property. Next one, another property of addition. Look at this. We have 12 plus 5 equals 5 plus 12. Remember, we talked about one of our members in class, his parent commutes to work. When you commute to work, you go one way and then the other. So the word commute sounds like commutative to me, and that's how I remember it. One way, 12 plus 5, then 5 plus 12. Next one. The 12 in the equation below represents the what of x? The answer is the coefficient. The way I like to remember it is that coefficient's the co-captain along with the variable, but one of the students in our class, an extremely intelligent, articulate student, suggested that the word coefficient sounds like coffee, and coffee and cream go together, or people love their coffee, and that's why it's associated with the variable. I think I like the student's suggestion better than my own. Next one, number 5. This line, BC, is known as the diagonal. Not the base, this would be the base. Not the height, that would be the height. Diagonal, diagonally across. Next one, number 6. This point points to the origin. This is where the coordinate plane originates. If I asked you to plot the point 3, 1, you would start here, you would originate here. We talked about in class people originating from various states, or indeed families originating from various countries around the world. Next one, number 7. Coordinate plane is divided into quadrants. All right, here we go. Quadrant means 4. 1, 2, 3, 4. Number 8. This image is known as a composite figure. It's composed of triangles, rectangles. There could be a semicircle. This is a composite figure, just like a sandwich is composed of peanut butter and jelly or ham and cheese. This arrow points to the vertex of an angle. Right there. That's where the two line segments meet. We call that the vertex. Next one. Expression below the 2 is known as a constant. This constant will never change. This term here, which is 13 times x, the value of this will change based on what x is. But this term will remain constant. Next one. The dashed line, that's the height of any object. It goes perpendicular to its base. That's the height. Horizontal lines on the top and bottom of this trapezoid, they are known as bases. These are legs, These are bases. Okay. 13x and 7x are known as like terms. A like term is when the exponent, a like term is when the variable is exactly the same, including its exponent. So let's talk about this a little bit. In this example, we have 13x and 7x. They are like terms because look, the variable is the same and the exponent's the same. As you know, folks, there's a hidden 1 above that x. Therefore, they are like terms. It doesn't matter that the coefficients are different. That's okay. It's the variable and the exponent. So now you may be saying to yourself, okay, what's the big deal if they're like terms? Well, here's the reason why it's a big deal. Because when you have like terms, you can combine them. So the fact that 13x and 7x are like terms means you can combine them and you can get 20x. Now you can't combine the 20x with the 8 because they are not like terms. This is like having an orange, 20 oranges plus 8 chickens. Okay. If I was to put a variable here, it would actually be x to the 0 power, because anything to the 0 power is 1. This would be here x to the first power. Same variable, but different exponent. Okay, we'll talk more about like terms, I believe, later in this video. The vertical axis the vertical axis on the coordinate plane is the y-axis. Okay, this is y, this is x. I've never really come up with a new good mnemonic device. I think it's just something that over the years I've just had to memorize. But if you folks think of one, let me know. But again, the y-axis is vertical, the x-axis is horizontal. Okay, percents. There's a lot of percents on this practice test, and indeed a lot of percents on your final. Excuse me. Okay, what percent of the figure are plus signs? You see this term what percent? Whenever you see words in math like what or how many, that's your unknown. That's what x is going to be. So if you see the words what percent, the first thing I would do is write down x percent. Okay, that's what we're trying to find. What percent of the figure are plus signs? Okay, so let's look at the figure. We have plus signs and we have multiplication signs. How many total are there? We have 2, 4, 6, 8, 10. 10 total. And of the 10 total, how many are plus signs? The question is, what percent is that? Okay. Now, remember, this percent sign can be replaced by division by 100. So we take away the percent sign and we replaced it with division by 100. Now we have a situation where we have to try to solve for x. And the way to do this is to ask yourself, how did I get from 10 to 100? The answer is you multiplied by 10. You do the same thing to the numerator to find the unknown. You multiply the 4 by 10 and you get 40. So that's your answer. The total goes on the bottom. The number that you're looking for, here 4 plus signs, goes on the top. we set that equal to x percent, which is then becomes x over 100. Look for words like what, how many, whatever follows words like that, that's your unknown. You set x equal to that. Next one. So your answer is 40. Okay, here we go. This is a word problem. Word problems, it's important to take notes as you go. I do it a sentence at a time. Sometimes I'll do it half a sentence at a time. Okay, chicken farm has sold 80 chickens. Okay, so we have 80 chickens. Of the 80, 20% of them were red. 20% of the 80. 20% of 80 were red. How many red chickens? Again, how many? Whatever follows, that's what we're trying to find. So if 20% of them were red, 20% of 80 gives us the number of red chickens. So we need to figure out what is 20% of 80. First thing I do when I see that percent sign is I replace it with division by 100. This of, think of it as being circled in, becomes a multiplication sign. And then 80 gets rewritten. And you can put a hidden 1 in here to set up your math. This is what we need to do to find our answer. Okay, let's make some room. Talk about how to do that. Okay. How do we do this? When you have a fraction and you're multiplying, you are allowed to multiply straight across. So one way to do this is to multiply 20 times 80 and get 1600. Multiply 100 times 1 and get 100. And now you have 1600 over 100. You cross out these zeros and your answer is 16. Okay, that's actually a pretty expeditious way to do this particular problem. Sometimes the numbers won't be this easy, and I'm a big fan of breaking down fractions. So let me show you how I would do this, how I recommend people do this. Okay. First of all, I'm going to move this 80 out of the way a little bit. And I'm going to rewrite this down here. I'm going to break down this fraction, 20 over 100. I always like to break down the smaller number first. So I break this down into 2 times 10. Then I ask myself, are either of these two factors present in the larger number? And the answer is yes, 10. 100 can be rewritten as 10 times 10. Now, because you have the same number in the top and the bottom with multiplication signs, you are allowed to cancel these 10s. So this now gets reduced to 2 over 10. We can reduce that further. The 2 is already a prime number, so that's 2 times 1. But the 10 can be reduced to 2 times 5. Now we can cross out these 2's, and the final reduction of 20 over 100 becomes 1 over 5. So now I'm going to bring this over here, and instead of 20 over 100, I'm going to use 1 over 5 to multiply by 80 over 1. Okay, so let me get rid of this. Folks, if you can learn how to break down fractions like this, I think your mathematical career will be a lot easier. Okay. So again, when we have this, you can multiply straight across and get 80 over 5 and then do division. So here we go. 80 over 5. Again, you multiplying straight across. Now, 5 is a prime number. Can't break it down any further. But does 5 go into 80? It does. 80 is none other than 5 times 16. You cross out the 5s and you get the same answer that we did originally. Next one. Okay. A restaurant has a floor that measures 200 square feet. The owner places carpet on 40% of the floor. How many square feet remain without carpet? Okay, I'm a big fan of drawing in math. So let's draw the restaurant. And there's a total of 200 square feet. The owner places carpet on 40% of it. So here we go. 40% has carpet. In this particular problem, they want to know how many square feet are without carpet. Well, if 40% is carpeted, 60% is going to remain uncarpeted. Now, they want the number of square feet. If they said what percentage of the floor remained without carpet, we'd be done. But the next part of this problem is we have to figure out what 60% of 200 is, because that's going to give us the number of square feet that are not carpeted. Okay, let's do that. We don't need our drawing anymore. Did its job beautifully. Now our problem is reduced to this. Okay. First thing, 60%. We can't work with percent signs. We change that to division by 100. The word of means multiply. 200 over 1 equals. That's what we're dealing with. Okay? Now, 60 over 100 is 0.6. So if you want to convert that to a decimal and do your multiplication that way, you're free to do so. But I want you folks to be very comfortable with fractions. So I'm going to keep this as a fraction. All right, now, let's break down 60 over 100 together. Always start with the smaller number. So let's break this down to 6 times 10. And now look for a factor here. And if both of them go into 100, pick the bigger one. So this is going to be 10 times 10. Okay. Because we have 10 on the top and the bottom, and because we have multiplication signs, we can cancel. Now, let's break down 6 over 10. Break down the smaller one first. Ask ourselves, are either of these factors within 10? Answer yes. 2 times 5 is 10. Cross out the 2. So we now have 3 over 5. So what I'm going to do is, I'm going to take this 60 over 100, and I'm going to replace it with 3 over 5. Okay, now, this is going to give us 3 times 200 over 5 times 1. Are any of these, excuse me, does 5 go into 200? It does. $40 times. So 200 can be written as 40 times 5. Okay, actually I don't want the parentheses there. Can we cancel out anything? Yes, we can. The 5s go. So your final answer is going to be 3 times 40, or 120. That's how I want you folks to learn how to break down fractions. So that's our final answer, 120. Next one. Write the ratio of 1 to 9 as a fraction. Pretty straightforward. There it is, 1 to 9. Next one. Oh, for your short answers, folks, if you'd be kind enough to put the number next to your answer. So if you were writing this as a short answer, if you could just do that for me. You don't have to show your work. I'm not going to take points off if you do not show your work. However, if you get an incorrect answer and you show work, more than likely I'll give you partial credit. In fact, I may even give you full credit. You know, if you happen to write this down wrong, like you write 1 over 10 by mistake, I know you meant 1 over 9. So, you know, I'll give a person full credit for that. In other words, listing your work along with what you submit on Google Classroom could only help you. I'll never take points off. Okay, here we go. What is 20% of 50? Let me write that down. 20% of 50. We cannot work with this percent sign. We change it to division by 100. This of becomes multiplication, and then we have 50 over 1. Okay? More breakdown of fractions. This becomes 2 times 10 over 10 times 10. 10's cancel. 2 over 10 becomes 2 over 2 times 1 over 2 times 5, or 1 over 5. So I'm going to take this 1 over 5 and I'm going to replace it. Replace the 20 over 100 with 1 over 5. Now we have 1 times 50, which is 50 over 5. We can break down 50 into 5 times 10. 5 stays the same. 50 becomes 5 times 10. We cross off the 5s. There's your final answer. 20% of 50 is 10. Now if you want, if it's easier for you, you could change this to 20 over 100 and say to yourself that's the same thing as 0.20, and multiply that by 50. You get the same answer. Okay, there's 2 decimal places because there's 2 items to the right of that decimal place, so you would get the same answer. If this is easier for you, that's fine. This is how I like to do it. I like to work with fractions, break them down, do the multiplication. because you will not have access to a calculator. That is not my rule. That's the way they do it in our school. Okay, next one. Write the ratio of 2 to 5 as a percent. Okay, if you're not sure what to do here, start out with what you know. So you know that 2 over 5 is a way to write that ratio. Now, how do you get this as a percent? Well, the way I like to do this is 2 over 5 equals what percent? 2 over 5 equals X percent. 2 over 5 equals X over 100. Okay, so what did we do here? Write the ratio as a percent. 2 over 5 equals what percent? That's our unknown. We're trying to find it. That's why it's X. What do we do when we see a percent sign? We replace it with 100. So now, folks, we have this. Okay, so I'm going to erase everything else. Let's focus on that. How do we get from 5 to 100? We multiply by 20. We do the same thing on the top, and if we multiply 2 times 20, X equals 40. So that's our answer. 2 over 5 equals 40 over 100. Next one. Justin has a collection of 80 comic books. Of them, 20% are Thor. How many Thors are there? So basically, we need to find 20% of 80. 20% of 80. That is 20 over 100 times 80 over 1. These can cancel. 2 over 10 is 1 over 5 times 80. And 5 goes into 80. 16 times. That's your answer. Or you could take this 20%. If you're comfortable with it, you can change that to 0.20. And you can do 80 times 0.20. There's a decimal place. There's 2 entities here. You move it twice over. That's your final answer. Whatever's more comfortable for you folks. Get rid of that percent sign. Make it 100 on the bottom. Or convert that right to a decimal if you're comfortable with that. Whatever works for you. Next one. Charlotte goes fishing with a guide. The guide charges her $86. Charlotte provides an 18% tip. How much total does she give the guide? Okay, so basically the guide gets $86 plus a tip, and that's going to give us our total. Now, they don't tell us what the tip is, but they tell you that she gives 18% of the 86. So what we're going to do here, folks, is we're going to get 18% of 86. And whatever this is, that's going to be the tip. And we're going to take this amount and insert it in there, and then we're going to add them up to get the total. That's our game plan. Okay, let's do that. Okay, I made this way too big. Apologize. Let's move that there. Okay. 18% of 86. How would I do that without a calculator? I would take that percent sign and get rid of it and replace it with division by 100. Of becomes times. 86 is 86. Okay. I would start breaking down fractions. So let's break this down. 18 can be written as 2 times 9. 10 can be written as, 100 can be written as 2 times 50. This becomes 9 over 50. I don't think you can break that down any further because 9 becomes 3 times 3 and 3 does not go into 50. Okay, so now we have 9 over 50 times 86. Okay, so I'm going to take all this away. And I'm going to move this over here. Now, we know that 50 can be 2 times 25. So, this is what we have. If we multiply straight across, we have 9 times 86 over 50. I'm going to rewrite 50 as 2 times 25. And I'm going to rewrite 86 as 2 times 43. Now these 2's cancel. So I have 9 times 43 divided by 25. That is an ugly number to work with. This is a case where it's easier to work with decimals. Okay, so I showed you that it's not always great to work with fractions. So let's change gears. Okay. That's why you have to know how to do it both ways. Let's use decimals for this one. 18% can be written as 18 hundredths, and that's 0.18. So we're going to do 86 times 0.18. 8 times 6 is 48. 8 times 8 is 64. Plus 4 is 68. Put a 0 down. Add. Because there's 2 items to the right of that decimal, we move it twice. There's our tip, 15.48. Okay? Let me erase all these fractions. It did not help us this time. Now I'm going to take this 1548 and I'm going to insert it right there as the tip. Okay, let me clean it up a little bit. So the total is going to be 86.00 plus 15.48. 8 for decimal 101.48. That's the total. That's what you would add in. That's what you would write in. Okay. Folks, I'm going to end the video here at number 23, and I'm going to do a part 2 as we move into this new topic, which is order of operations, otherwise known as PEMDAS. So there will be a part 2 to this video, which picks up at number 23.